Okay, so last time, ano yung ginawa natin? So last time we discussed equilibrium. So we said that equilibrium is a system or a state of system in which the forward and the reverse reaction are equal, no? So that means yung flow ng reactants to products and products to reactants ay equal. Okay, so that means yung ating reactant na convert into product and at the same time yung product na convert back into the reactants na. So, ikot-ikot lang yung ating substances no. And yung balance ng pag-convert niya from one species to another, tawag natin doon ay equilibrium no. And also, equilibrium systems are described by their equilibrium constant expressions, no? Or yung K natin. So K is equal to the concentration of products over the concentration of reactants, no? Okay. So in ano, ang way ng pag-write ng ating equilibrium constant is products over reactants, no? So suppose we have this system, yung C and D, yung capital letters C and D, there are yung chemical species natin. And yung small letters, yun yung ating coefficient, no? So for this equation, if you're going to write the equilibrium constant, that will just be K equals products C, D. Okay, so you have your C, D in square brackets. And yung kanilang coefficient that will serve as their exponent. Okay. Over reactants, so we have A and B here. Yung kanilang coefficients that will also serve as the coefficients. Okay. So, ganyan mag-write ng equilibrium constant. What else, no? I told you last time that species in aqueous and the gaseous phase, no, are to be written in the constant, no? So, yung aqueous and then yung gaseous, pwede mo siya isulat sa equilibrium constant. However, yung ating solids and liquids, we do not write them in the equilibrium constant, no? Okay. The reason for that will be discussed next meeting. No? Okay. So again, aqueous and gaseous phase lang yung pwede isulat dito. Okay. So there are two types of K, no? The first one will be in terms of concentration. So yun yung ating expression in which these species are expressed in concentration units, no? Such as molarity. Okay, tawag natin dun sa K na in terms of molarity, Kc yun, no? Ang tawag naman natin sa K that is in terms of pressure units is Kp. Okay, so dalawa yung uri ng K. We have the Kc and the Kp. For equations with aqueous species only, so we only have Kc, no? Kasi hindi nag-exert ng pressure yung aqueous species, no? Pero kapag we have aqueous species, we have both Kc and Kp, no? So again, kapag aqueous, Kc lang. Pag gaseous, Kc and Kp. Then what else, no? We shown the relationship of Kc and Kp given this equation. Okay, so suppose Kc was given and you are asked to solve for Kp, then you can use this equation and vice versa. Okay, and then we answered some problems in which the chemical substances are already in equilibrium. Okay, and then we also discussed last time yung operations involving equilibrium constants. No? So I told you last time that whenever you multiply the equation by 2, you get the square of the k value. No? If you divide the equation by 2, then you take the square root of the original k value and so on and so forth. No? Okay. Then when you reverse the equation, what happens to your k value is that it becomes the reciprocal of the original value. Okay? So kapag flip mo yung equation mo, babaliktad. Magre-reciprocate yung k value mo. And then when you combine equations, what happens to your k value is that they are just multiplied. Okay. And also, we discussed last time that we can predict where the reaction is going with the help of reaction quotient. Okay, so we can tell where the reaction is going by comparing the reaction quotient Q with the equilibrium constant K. Now, so depending on their values, they can either go to the left, to the right, or just stay. So when your Q is less than the K, then it means your reaction is going to the product side, no, in order to establish equilibrium. When your Q is equal to K, then the system is already in equilibrium. There will be no net direction, no, kasi balance na. And lastly, when your Q is greater than K, that means your reaction will proceed towards the reactant side, no, in order to establish the equilibrium. Okay. So yan, nagsagot-sagot tayo. And then we will now proceed with the second part of our discussion. Okay, so this will also be the last part of this session ng equilibrium na chapter 3. Okay. So by the way, with regards to chapter 3, I uploaded the part 1 of the worksheet with answers. This will serve as your reviewer na rin. So I posted last time itong additional resource material on Canvas, no? So andito yung link sa aking channel. Andito yung playlist, no? If you want to watch my laboratory lessons, then look out for videos with titles. Ayan, no? And if you want to watch lecture videos other than your section, hanapin nyo lang yung mga section na yan sa playlist natin. Okay? And then sabi ko diyan, I will upload the answers with the with worksheets, no. Okay. So for equilibrium, I already uploaded the part 1 kung ano yung diniscuss natin. Naglagay ako ng questions dito. You may want to answer them first, no, before you check the solution at the next page. Okay? So yan, ganyan ginagawa ko kasi sa aking lab class, no. So that they will be guided, mas madugo kasi yung calculation sa lab, no. So ayan. So for lecture, ayan, if you want to review na after this session, then you may. Kasi may quiz din tayo, no. Ay, malapit na tayo mag-quiz. Okay, so ayan na. Sagutan nyo muna yan on your own, then look for the answers. With explanation here at the following pages. No? Okay, so sa laboratory, kung gusto nyo rin tumingin ng mga answers sa worksheet, okay, so ayan lang, click nyo lang yan. So for laboratory, solutions, and dito yung mga pinagsasagutan namin last time with answers and explanation. Okay, so ayan. So hopefully makatulong to sa review nyo, no? Okay. Ayan. Ito naman sa chapter 2 namin, yung statistics, no? Ayan. So, if you want to recall your stats, then just go here. And then, ito yung recent namin, chapter 3, gravimetry, which is, as of this case, nahihirapan sila sa quiz, no? Ayan, pero andito yung reviewer. Okay, so hopefully makatulong sa inyo tong reviewer na to, no? Ayan. For the part 2 of the chapter 3, I will upload that around weekend uli. No? Weekend ako nag-upload ng answers sa worksheets. No? So, ganun ha. Hopefully, gamitin nyo yan para may reviewer kayo. No? Bukod pa yan sa i-upload kong reviewers for the exams. Okay? Kasi mahirap yung anak alam ko na nakikita nyo na mahirap talaga siya. No? Kaya yun, that's the best I can do for you, no? Para matulungan ko kayo sa review. Okay? So, yan lang. Again, lahat ng worksheets andito na. Please download them. No? And study them thoroughly. No? And check for typographical error because I commit those. No? So, yan. So, that will be yan. Yun na yan. Lipat ko lang tong tab sa kabila. Ayan, pakigamit na lang yung worksheets ha, pag nagre-review kayo. Kung gusto niyo yun sa lab, kunin niyo na rin yan, no? Okay, para may additional reviewer kayo. Okay, so let's proceed with the equilibrium calculation. Okay, just as I told you earlier, no, kanina lang sabi ko sa inyo, yung mga problems natin before, it expresses the concentration of the substances in equilibrium na, no? So for example, itong problem na to, okay. So for example, itong mga to, ayan, yung mga concentration na yan, mga pressure na yan, they are already in equilibrium, no? And then I discussed yung direction of reaction. So dito sa direction of reaction, ang binigay ko sa inyo ay yung initial concentration, no? Ngayon, dito na tayo sa second part ng session natin. So, suppose I give you the initial concentration of the chemical species. Suppose, doon ako nag-umpisa. Binigyan ko kayo ng initial amounts ng species natin. Will you be able to solve for their equilibrium concentration? Okay, pwede mo ba malaman yung equilibrium concentration nila? Okay, so the answer there is yes. No, so we can solve mathematically for the equilibrium, for the equilibrium amounts, no, or equilibrium concentration, no, even yung initial amounts ng ating substances. Okay. Okay, so again, no? So again, kanina, ang binibigay ko sa inyong problems last time ay yung nasa equilibrium na, no? Then, nagbigay din ako ng problem na initial amounts lang yung binigay ko. Then, what if gusto ko kunin yung equilibrium amount, no, from my initial amount, no? So, that means the reaction started going towards its desired direction na. So, ano na gagawin ko? Pwede ko ba malaman yung equilibrium concentration from the initial? Sagot doon ay yes, no? So, in order for us to determine the concentration of our chemical species at equilibrium state, with the knowledge of their initial concentrations, we have to use what's called the ice table. Okay? So the ice table will help us track down the changes in the amounts of the reactants and the products in the chemical reaction as they achieve equilibrium. No? Sometimes no, sa ibang literature or sa ibang prof nyo, tatawagin nila yung rice table. No? Although for me, I would just call it ice table. Okay. So how do we solve for the equilibrium amounts of our chemical species? No? So in answering problems with regards to ice table, number 1, express the concentration of all species in terms of the initial concentration and a single unknown quantity x, which represents the change in concentration. So bale sabi doon, isulat mo muna yung initial amounts nila. Okay? And then you express the changes in their initial amount with x, no? X kasi you don't know how much it will change, no? So hindi mo alam kung gaano karami siya madadagdagan or gaano ka onti siya mababawasan, no? Okay? So you express it with a known variable x, and then uh, later on, you will plug in the expressions for equilibrium concentration in the equilibrium constant, and then you solve for x. No? So that involves algebra. And once x is determined, you can now recalculate for the equilibrium concentration of all other species. So ano yung meaning niyan? Okay, so ganito. Punta tayo sa isang problem. Okay, so ito yung meaning ng steps 1, 2, 3 na yan. Okay? So suppose we have this problem here. Isomers of steel bean have an equilibrium constant Kc equal 24 at 200 degrees Celsius. The equilibrium equation has been written here now. We have the cis steel bean and equilibrium with trans steel bean now. Suppose initially there are 0.85 molar of cis isomer Calculate the equilibrium concentration of all substances. Okay? So yan. Ito yung setup ng problem na to. It will give you the initial concentration and then you will be asked ano yung equilibrium yung concentration niya. Okay. So ang ibibigay ay initial, then ang hinahanap ay equilibrium. Okay. So kapag ganun yung setup ng problem nyo, you need to use the ICE table. Okay? Or the RICE table. No? Okay. So, paano yun, sir? Okay. So, since table yan, gagawa tayo ng table. Okay. So, you first write your reaction. So, we have the cis still bin. Gawin ko na lang cis, no? And the cis is an equilibrium with the trans isomer. Okay. So, yan yung reaction. And then, I set up my I, my C, and my E. Kung nagawa niyo na 'to sa Janchem, good 'yun, pero if hindi or nakalimutan na, so ito na 'yun 'no, ginagawa na natin. So again, paano natin sasagutan yung problem na 'to? It is necessary for you to create this table, okay? So you cannot skip this step 'no. So gawa ka ng table where you show the reaction and the ICE, okay? So ayan. So, ano yung I, no? So, yung I sa ice table ay initial amounts, okay? So, it could be in concentration units or in pressure units, depending on the problem, okay? So, in our case, the initial amount is, for cis isomer, that's 0.850 molar, okay? I will not write the unit na lang, okay? So, again, I is initial amount, no? Whatever is said in the problem, kung ano yung initial amount nun, yun yung ilalagay nyo sa I niya. Okay. So for the cis isomer, that's 0.85. How about for the trans isomer? For the trans isomer, we do not have any. Okay. So zero yung concentration ng trans natin. Okay. So, yan. Ganun lang gagawin nyo. For the I, initial, you determine kung ano yung initial amounts from the problem. No? In our case, this is 0.85 molar. For the trans, nothing was given, so zero yon. Okay? So, we solve for the equilibrium concentration na. Okay, so tapos na tayo sa I, initial. How about C? C is change in the amounts. Okay. And sabi sa ating paragraph kanina, we express the changes in terms of a single unknown quantity x, no. So ito, x na yung value natin dito. Okay, so x na yan. However, dalawa yung uri ng change. Pwedeng negative x or positive x. So negative x if mababawasan yung if mababawasan yung ating species so that equilibrium can be achieved. Pwedeng positive yung x kapag madadagdagan siya in order to achieve equilibrium. Okay, the question there is paano po natin malalaman kung siya ay positive x or negative x. Okay. So the answer for that is the predicting the direction of reaction. Yun diniscuss ko last time. Okay, you have to determine first where the reaction is going. How? You compare the Q with the K. Okay? So gawin natin yon. Let's compare Q and K so that we will know whether the change is positive or negative for each chemical species. Okay? So hanapin natin yung Q muna. So as I told you, Q is similar with K. So that is still product over reactant. Okay. So for the product, we have the trans isomer initially and the cis isomer initially. Okay. So we have the trans on the numerator kasi nasa product siya. Yung initial concentration lalagay natin. And yung cis, yung nasa baba. No? Yung initial concentration niya. So ano yung concentration ng trans? Wala. So, 0. Ano yung concentration ng cis? 0.85. Okay, so ito, no-brainer na to. 0 divided by 0.85, edi malamang 0 yung value ng Q natin. Okay? So, since our Q is 0, we will now compare it with the KC. Okay? So, gawa kayo ng number line. So, KC is here. 24 yung value niya. Sa number line na yan, asan si Q? Of course, nasa left si Q kasi 0 yan. So, in order for the reaction to achieve equilibrium, your reaction must proceed towards the product side. Okay, so Q must go to K, to the right side. So, equilibrium will be achieved. Okay? So again, bakit natin ito ginagawa? Bakit natin ginagawa yung comparison ng Q and K? In order for us to determine if our change is positive or negative. Okay? So, pwede kasi ito positive, pwede ito negative, or vice versa. How will we know that? Just compare the Q and the K, no? So, yung Q ginagawa na natin to last time, yung comparison ng dalawa. So, this should be familiar. Okay, so again, kapag 0 yan, it will proceed towards the product side, no? So, yan. So, paano ko po yun isusulat dito sa ice table natin? How will I show that the reaction is going to the product side? Okay, ganito lang po. Since the reaction is going to the product side, that means the concentration of trans isomer will increase over time. That means positive X yun. Kasi the concentration will increase. Kasi sabi natin, ito mapupunta sa product side. So, ibig sabihin, madadagdagan yung trans isomer natin. By how much? I don't know. Kaya X yung nilagay ko. Okay? So, this will increase by X value. How about the cis isomer? Okay. So, since the reaction is going to the product side, that means your amounts of the cis isomer will decrease over time. So, mababawasan yan over time. So, that will be negative X. Okay? So, ano uli nangyari? So, what happened is that I compared Q and K, so I will know where the reaction is going. Then, since I determined that the reaction is going to the product side, that means your product side will have positive X values. Madadagdagan kasi sila, kaya positive sila. Your reactant side, on the other hand, will be negative in value, or negative X, kasi mababawasan siya to a certain degree in order to achieve equilibrium. Okay? By the way, no, question doon, sir, what if may coefficient to? Kunwari, 3 cis tapos 2 trans. Okay. Kapag may coefficient ang iyong substance mo, kunwari ito, may 3 yan sa harap, you multiply it with the x. So, bale, this will become negative 3x. No, kunwari ito, may 2 sa harap, this will be positive 2x. So, coefficients are multiplied with the value of x. No? So, ganun lang gagawin nyo. Okay, so we are almost done with the calculation. So initial amounts, whatever is said in the question, you write the info here sa I. X, yun C pala. C is the change, no? So you determine kung sino yung madadagdagan, sino yung mababawasan by X factor, no? Okay, so how will you know kung sino yung positive, negative? Compare Q and K. Okay, so nagawa na natin ito last time, so alam nyo na yan siguro. Then how about E? Equilibrium. So kapag E, ayan ay equilibrium na. What will be the equilibrium amounts of cis and trans? No? So, in order for you to determine equilibrium amount neto pati ng trans, you are just going to combine I and C. Okay? So, pag-add mo lang to, I pati yung C. Pagsamahin mo yan to get the equilibrium expression. So, for cis isomer, at equilibrium, its concentration will be 0.85 minus X. Mababawasan pa yan, no? By X, no? How much yung X? I don't know yet. Okay? So the equilibrium concentration of cis is 0.85 minus x. How about the trans? For trans isomer, that will be 0 plus x. No? So basically, that's just x. Okay. So again, ano gagawin mo sa equilibrium row? Sa equilibrium row, what you're going to do is just to add I and C. Okay? So pagsamahin mo lang yung I and C, you will get the E, no? Yung equilibrium. Okay? So ganun lang yung pag-setup ng I stable. And then the rest is algebra. Okay? So start na tayo sa algebra ulit, no? So, in order for us to determine the value of x, now let us express the equilibrium constant. K is equal to product over reactant. That is the concentration of your trans at equilibrium and the concentration of your cis at equilibrium. What's the value of K? That's 24. What's the equilibrium expression for your trans? That will be X. Ito yun, no? 'Di ba equilibrium yan? Ito yun. Ayun, X. You just plug this into that. Okay? So, ganun lang. Lalagay mo lang yung X doon. How about the equilibrium concentration of cis? That is 0.85 minus X. So, I'm going to write it down here. Hulaan yung sunod na mangyayari. We solve for the value of X. Okay. So, we solve for the value of X. Paano yan? Cross multiplication, then divide. Okay? So, hopefully may space pa ako to do that. Okay, so I will cross multiply the denominator on the other side. So I will have 24 times 0.85 minus x equal x. I will distribute 24 to my to my term, no, yung binomial natin. So solve natin 24 times 0.85. Okay, so that will be 20.4, tama ba? Okay, 20.4 minus 24x. Then, ano gagawin mo yung x? Pagsamahin mo. So, I will transpose my 24x to the other side. No? So, ano, magiging ano yan? 20.4 equals 24x plus x. Okay. So, when you transpose numbers, no, na addition, subtraction yung sign niya, pag nilipat mo yun sa kabila, mag-change lang siya ng sign. No? Kunwari, negative yan sa left. Pagdating sa right, positive yun. Okay. And vice versa. Kapag positive yan, pag nilipat mo sa right, magiging negative yan. Okay. Okay. So, yan. Zoom in natin. Okay. So, again, ano na nangyari dito? So, basically, I just express the equilibrium constant of the reaction. So, that's K equals products over reactants. In our case, that's trans over the cis concentration at equilibrium. Using the ice table, we know that the concentration of trans at equilibrium is X. So I plug it there. And for the cis, we know that the equilibrium concentration of cis is 0.85 minus X according to the ice table. Then we now solve for the value of X. Okay, so again, I cross multiplied this term to 24. I distributed 24 to my binomial. And then now I solve for X. Now, let's continue. Okay, so 24x plus x will be 25x, and that's equal to 20.4. So in order for us to solve for the value of x, you divide both sides by 25. So we solve for the value of x equal to 0.816, no? 0.816. Okay, so that means the value of x is 0.816. No? We're not done yet. No? Ano ba tinatanong? Yung equilibrium concentration. What we were just able to solve is yung value lang ng x. How are we going to solve for the equilibrium concentration? You plug in the x dito sa ice table natin. Okay? So, ipa-plug in mo yan dyan. So, yung 0.816, yun yung value ng x. So, we can now solve for the equilibrium concentration of cis. That will be 0.85 minus 0.816. And yan ay equal sa 0.034 molar for the cis. Okay, so yan na yung sagot natin. The cis isomer at equilibrium will be 0.034 na lang. Okay, so ang baba na ng amounts niya, no? Okay. So at equilibrium, yan na yung amounts niya. How about the trans, no? Since the trans is just x, okay, so that means kung ano yung x natin, yun na yun. Okay? Wala na tayong gagawin. That's the concentration of your trans. Okay. So that's how we calculate for the equilibrium amounts of our chemical species, no? With the help of ice table. So again, let's recall what happened. No? So what happened is that we have the equation, it gave us the initial amounts, and then it asks us about the equilibrium amounts. So in order to answer that, we use ice table so we can track the changes in the concentration of our substances. So ice table, I initial yon. So that means whatever is the initial concentration stated in your problem, isusulat mo doon. C is the change by how much will your substances change, no? So for change, it could be positive, it could be negative for the products or the reactants. So if you want to determine kung sino yung positive, sino yung negative, you have to compare the Q and the K. And again, depending on the value of Q and K, you can have positive or negative X now. So if your Q, nasa na yun? So if your Q is less than K, then the reaction will proceed towards the product side. That means the product side will be positive X and the reactant side will be negative X. If your Q is greater than K, then that means your products will convert to reactants. Okay. So, ibig sabihin nun, positive yung reactant, negative yung products. Okay? So, ganun lang. So, in our case, Q is less than K kasi 0 yung Q kanina. Sinolve natin yon. So, since 0 yung Q, K is 24. That means the reaction is going to the product side. Hence, the X for the products should be positive. So, positive X for the product, negative X for the reactant. Also, if you have coefficients, you have to multiply it to the value of x. No? So, kunwari may 2 dito, 2 cis, dilagay mo 2x. Okay. Kunwari ito may 3, dilagay mo 3x. No? Again, coefficients are multiplied with the value of x. For equilibrium, you're going just to add I and C. Okay, so pagsamahin mo lang sila. And then after writing the ice table, pag nakuha mo na tong E na to, you now solve for K, no? So the K is equal to trans over the cis, okay? Ano yung concentration ng trans at equilibrium? That is X. Ano yung concentration ng cis at equilibrium? 0.85 minus X. No? So kung ano yung ilalagay mo dito, just look at your ice table. Plug in mo lang yon, and then you plug in the value of K, that's already given naman, and then you solve for the value of X. Algebra. Okay? Then, pag nasukuha mo na yung X natin, in our case, that's 0.816. Pag nakuha mo na yung value ng X natin, that will be plugged in into the E for the equilibrium concentration. So, yung X value, lalagay mo dito. So, you can solve for the equilibrium amounts na. Okay, the cis isomer will be 0.85 minus x, so that will be 0.85 minus 0.816 or 0.034 molar at equilibrium. Ngayon yung concentration ng cis at equilibrium. For the trans, x yung concentration niya at equilibrium, so that means it will just be 0.816 molar. Okay? So, ganun lang. Yun na yan. That's how we solve for the equilibrium concentration given our initial amounts. We use the ice table. Let's proceed with the next problem. No. By the way, may calculator technique dito. Siguro bukas ko na lang i-upload. No? How to use your calculator to solve for the value of x. No? For now, mag-manual tayo. Then by tomorrow, mag-record ako ng video on how to solve for x using calculator. Okay? Para mapadali buhay natin. Kung kaya ng calcu nyo. So, antayin nyo na lang yung video ko na yun. Maybe tomorrow I will record that. No? Okay. May holiday naman tayo sa Thursday. So, let's try this problem. A mixture of 0.75 moles of hydrogen and 0.75 moles of iodine gas was placed in a 1-liter vessel, no, steel flask, at 430 degrees Celsius. The equilibrium constant Kc for the reaction is 54.3 at this temperature. Calculate the concentration of H2, I2, and HI at equilibrium. Okay? So again, let's take a second look sa problem. So it gave us the initial amounts. Ano yung initial amount nila? 0.75 mole of H2 and I2 in 1 liter vessel. And ang hinahanap sa problem ay yung equilibrium concentration. So whenever you are given the initial amount and hinahanap yung equilibrium amounts, you are going to use ice table. Okay. So let us set up our ice table here. So liitan lang natin onte. So we have the H2, kulay black na, sige. We have the H2, the I2, and that is an equilibrium with 2 HI. O, sulat mo na ice, no? Ice. Okay? So, necessary to. You cannot skip this part, no? Kung tinatamad kayo gumawa ng table, wala tayong magagawa, no? Necessary kasi yan. Okay? So, you're going to construct your ice table, and we already have that on the left side of the slide, no? So, lagay natin yung info about the initial concentrations nila. Saan mo makuha yon sa problem? Basahin natin. 0.85 mole of H2, 0.75 mole of H2 and I2 pala. Okay. So, pwede ba moles ilagay ko dito? Hindi, no? So, kailangan concentration units ilalagay mo dyan. It's either molarity or pressure. Okay? So, paano mo gagawing concentration to? Moles to. You divide it by the volume. Okay, so the volume is already given. 1 liter naman yon. So, this divided by 1 liter is 0.75 molar. Okay. So, again, initial concentrations are are in units of molarity and pressure only. No? Yun lang, hindi na pwede yung moles at iba pang concentration units. You have to convert. No? Okay? So, lagay natin dyan, 0.75 molar H2 and 0.75 molar I2. Sir, paano po uli naging 0.75 molar? What we did is that we divided the moles by the volume. So, 0.75 divided by 1, edi yun din, 0.75. No? So, molar concentration na yan. So, you have 0.75 H2, 0.75 I2. How about HI? Meron ba tayo? Wala. Walang sinabi sa problem. So, that will be 0. Okay? So, kapag walang sinabing amount sa problem, 0 agad. Okay? Now, let us solve for the change. No? Tignan natin yung change. Will the reactant increase or will the product increase? No? So, paano yung change? Magagamit ako ng x, no? Unknown variable x. Lalagay ko x, another x, and then we have 2x this time. Bakit, sir, naging 2x yan? Okay, sabi ko kanina, if you have coefficients, you multiply your x with that. Okay? So, ano coefficient nito? 1. So, 1x. Ito din, 1x. Ito, 2x. Ano to? Ang coefficient niya ay 2. So, that means the change will be 2x, no? For this part. Okay, it follows the conservation of mass, no? Yung ating stoichiometry. So kung ano yung coefficient, ganun karami yung change niya. Twice, no? Yung change niya. So that will be 2x. Again, pag may coefficient, you multiply with the x. Ngayon, question. Sino yung positive, sino yung negative? Okay? So ito, ganito na lang gagawin nyo. Kapag wala kang product, then the reaction will proceed towards the product, obviously. Okay? Kasi wala siyang product eh. Zero yung value ng Q nun. Di ba? Product over reactant. So if you do not have any products, 0 divided by a number is equal to 0. Okay? So that means Q is 0 and it has to reach K to achieve equilibrium, no? So ibig sabihin nun, pag 0 yung concentration ng product mo, positive yung change sa product. Okay? So hindi ko na isosolve yung Q. Kasi kapag 0 yung product, alam ko, ang Q ko ay pupunta sa right side or going to the product side, no? So that means the change for the products will be positive and the change for reactants will be negative. Okay? So ganun lang. Ayan. What if sir may concentration 'yan? Edi doon ka na mag-solve ng Q, okay? Pero kunwari zero na yung product, edi going to the product side 'yan obviously. Okay? Sir, what if zero yung reactant? Edi going to the reactant, okay? So kung sino yung zero, doon pupunta yung reaction. Okay? So ganun lang. Pero kapag yan may number yan lahat, you have to use the Q and K talaga. Okay? So yun lang yung technique. Kapag zero yon, dun pupunta yung reaction. Then what's next? What's next is that we solve for the equilibrium concentration of H2, I2, and HI. So pagsamahin mo lang yung I pati yung C. So that will be 0.75x minus x rather. 0.75 minus x and 2x. Okay, so I will just combine I and C. Pagsamahin mo lang yung dalawang yan, so you will get this. This plus this equal this plus this equal this plus this is equal to this one. Okay, then what's next? So once I'm able to set up my K, my I stable rather, I can now solve for the K. So let us express the equilibrium constant for this problem. For the product side, we have 2 moles of HI. So we can write this as HI squared. Okay? Zoom in ko dito. Yan. For the reactant side, sa denominator, that will be the concentration of H2 and I2 multiplied together. So yan yung equilibrium constant natin. And then, we plug in all the numbers we know. Okay. So for K, that is actually given already, 54.3 daw yung value ng K. So that will be 54.3 for K. How about the equilibrium, how about the equilibrium concentration of HI? Sabi sa ice table, the equilibrium concentration of HI is 2x. So ipa-plug in ko yon dito. So that will be 2x pero naka-square pa. Okay? So yan. Bakit 2x sir? Kasi yun yung nasa ice table ko eh. Yung E for HI is 2x. So yan, 2x. Tapos naka-square pa yon. How about H2 and I2? For H2 and I2, they are both 0.75 minus x. So I will plug it there. Okay, so plug in mo lang. You have 0.75 minus x. Dalawang beses yon sa denominator. You have your 2x. quantity raised to 2, and that is equal to 54.3. Now we solve for the value of x. No? So ito, algebra na to. Wala na uli chemistry dito. So anong gagawin natin sa nasa baba? That will be FOIL method yan. No? Okay? So first, outer, inner, last. Multiply natin yung lahat. Okay? So ito, sundan nyo na lang. No? Sulat kayo. No? I-FOIL method nyo tong nasa baba. So we will get the expression here. Sana kayanin ng space natin. So, yung taas, yung numerator, what's 2x quantity raised to 2? Magiging 4x square yon. Okay? Yung 2 may square, yung x may square din. So, we have 4x square. About this bottom part, no? So, let's do the FOIL method. First term, 0.75 square. Sulat natin, that will be 0.5625. How about the outer and the inner, no? So if you have a square of binomial, ano sabi natin doon? Kapag square ng binomial, twice the product of the first and the second term. No? Kapag pinagsama mo yung outer pati inner, ito times 2 mo lang yung product nitong dalawa. Okay? So if you could still recall your algebra, this is a square of binomial. Kasi parehas silang same lang. So, same lang yan, minultiply together. So, square of binomial yan. So, ano formula kapag square ng binomial? A square plus 2ab plus b square. Okay. So, we have a square, ito yan, plus 2ab. Okay, so let's multiply 0.75 and x, then square natin yon. So, 0.75 times negative x. So, that will be negative 0.75. Then, square natin. Times 2 pala, rather. So, ano yun? 0.75x times 2, 1.5 na. Okay, so that will be negative 1.5x. Okay, so that will be negative 1.5x na. Yun yung twice ng a and b. Okay. And we squared the last term. That's negative x times negative x. So that will be positive x squared. Diba? Umagang-umaga, nag-algebra tayo, no? Saya ng buhay, diba? Okay lang yan. We have no choice. Ayan. So, yan. Nag-FOIL method na tayo. Okay? So, we squared the binomial. We squared the A. Ito yon. We twice the product of A and B. Ito yon. And we squared the B. No, ito yon. Pero again, what if, sir, magkaiba yan? E di FOIL method yan. First term, outer term, inner term, last term. Yan yung mga i-multiply mo. Okay? So, yun kapag magkaiba yan. Pero kapag yan ay binomial, tas parehas lang yan, multiply mo sila, square of binomial yon. Okay? So, what's next? What's next is that I will transpose this dito sa other side. Okay? So, i-cross multiply ko siya doon. So, we have 4x squared, and then I will multiply this dito. Nilagay ko yung 4x squared sa left side kasi hindi nakasya dun sa right side eh. Hindi nakasya dito sa left side ito kapag pinagsama ko yun. So, pinag-switch ko na lang. Ito yung nilagay ko sa left, tas yung product nito yung sa right side. Okay? Okay? So, ayan. Anong gagawin mo dyan? You distribute 54.3. You distribute that to your terms. Okay? So, lagay mo yan dito. Distribute mo yan dyan. Doon and doon. Yan. Distribute. So, sulat ko lang yung kanilang ha. So, 54.3. 0.5625. That will be 30 54375. Okay. So, yan yung 54.3 times 0.5625. Then, mo-multiply ko yan sa negative 1.5x. So, 5. So, that will be negative 81.45. 81.45x. And then lastly, 54.3 x squared. No. So, yan. And then, what I'm going to do next, no? So, yan. Minultiply ko lang yung term sa individual terms sa ating equation, sa ating parenthesis. Ang susunod kong gagawin, I will format my equation as ax squared plus bx plus c equal 0. So, itong ating last line, gagawin natin yung equal to 0. Okay, so we will follow this format. Ax squared plus bx plus c equals 0. Okay, so gagawin lang natin itong 4x, lipat mo lang sa kabila so that this side will be equal now to 0. Okay, so let me write it here. That will be 35,4,375 minus 8,145 x. Kapag yung 4x square nilipat ko sa kabila, that will be negative 4x square na. Tapos may 54.3x square ako. So 54.3x square minus minus 4x square, that will be positive 50 na lang, no? 50.3x square. Okay, so bakit sir naging 50 yon? Kasi again, yung 4, sinubtract ko na sa 54. Okay. Kasi di ba nilipat ko to sa zoom in ko ulit. Yan. Di ba itong 4x squared nilipat ko na sa kabila. So pag nilipat ko yun doon, magiging negative yan. So ima-minus ko na yan dito sa 54. So that will now be 50.3x squared. Format natin yan, ax squared plus bx squared equals, plus c equals 0. So let's format this equation into that. Mauna yung x squared, obviously. Sunod yung x, no? So that will be negative 81.45x. Last yung coefficient, yung number lang. Sana kasya. 54375, 4375. Okay, so now we solve for the value of x. No? So ano yung value ng x? We can use the quadratic equation. Okay? So again, yung calculator shortcut, separate video na lang yon, upload ko na lang sa sa YouTube ulit. Tapos bigyan ko kayo ng link para makita nyo yung calculation technique dito. Okay. So ano yung quadratic equation? Google ko lang, di ko rin kabisado. Kinakalkyo ko lang kasi ito. Quadratic equation. So quadratic equation will be used to solve for the value of x, no? Okay, and ang formula niya is x equals negative b plus minus square root of b squared minus 4ac divided by 2a. Okay. So that will be negative b squared plus minus square root of b squared. I mean negative b plus minus square root of b squared minus 4ac all divided by 2a. So since you have a binomial, I mean quadratic equation pala. So since may quadratic equation tayo, we can solve for two values of x, no? Pwedeng dalawa yung maging value ng x natin. Bakit? Because of this positive negative sign. Pwedeng positive muna, then yung isa negative muna, no? Okay? So yan, ang gagawin nyo lang, you will plug in A, B, and C sa calculator so we can solve for the value of x. No? Dalawa yung value ng x natin. Sulat ko dito, x1, x2. Okay. So, sir, ano yung A, ano yung B, ano yung C? Okay, ganito lang. Kung ano yung coefficient ng x square, yun yung A. Ito yun. Kung ano yung coefficient ng x, yun yung B. Kung ano ito, yun yung C. I-plug in nyo yan sa calc nyo. Okay. So, yung calculator shortcut, separate video na lang yan na para enrichment lang naman yun. Ito pa rin naman yung main concept. Plug in natin sa calc yan ha. That's negative B, positive muna. Then yung sumunod na x, negative square root of B square minus 4AC. Paki-plug in ng maigi. Sir, ito question ko po, sir. Ako na yung nagtatanong sa sarili ko. No? Negative po ito. Tapos minus sign doon. Opo, okay. So ito negative na, tapos pa-plug in mo doon sa negative uli. So negative, negative yan. Double negative yan. So negative times negative this term. Okay. So ayan. So ayan. Pagsamahin mo lang yung parehas na negative. So that will be positive na. Okay? So paki-plug in na lang sa calculator nyo. Ako, mag-shortcut ako. Siguro yung manual solving gawin nyo na lang after the class. Ha? May holiday naman tayo sa Thursday. So you have plenty of time to solve for that. And yung sa worksheet, ang ipapakita ko doon value ng xi, naka-quadratic equation. So kung gusto nyo antayin nyo yung worksheet, okay lang na. So ganun. So plug in nyo yung ABC dyan sa equation. So 81, 45, 30, 54375. Na-solve ko na yung value ng x. Agad-agad. So, ano yung value ng x ko? The first value of x will be positive 1.029. The second value of x will be positive 0.5898. So, that will be 590 na lang. So as you can see, I have two values for x, no? It's either 1.029 or 0.590, no? Isa lang dapat yung value na x na gagamitin ko. Hindi pwede dalawa, no? So it just happened na dalawa yung lumabas because of the quadratic equation, positive minus square root of something. Okay? So yun yung dahilan bakit dalawa yung value ng x ko. Dahil dun sa plus minus sa quadratic equation. Pero, sa aking ice table, isa lang yung gagamitin ko dyan. So, which one will be it? No? Is it the 1.029 or 0.59? So, tingin tayo sa ice table. Let's check kung sino yung magme-make sense sa dalawa. Diba? Tingin tayo dito sa H2. So, for H2, we have 0.75 minus x. Imagine nyo, yung x nyo ay 1.029. Okay? So imagine your x is 1029. What will be the equilibrium concentration for H2? That will be 0.75 minus 1.2905, which is a negative number. Does it make sense na yung concentration ay negative? Hindi, no? Walang negative na concentration. Okay? So, ganun gagawin natin. Sa two values ng x, you will check who among them will make sense, no? If it will give negative, it will give negative concentration, then that's not the correct value of x that we are looking for. Okay? So that means yung 1029 x is yan. Bakit? It doesn't make sense, no? Kasi kapag plinag-in mo yan dito sa ating ice table, 0.75 minus 1, that's a negative number. Okay? So, ayaw natin yon. Kasi walang negative na concentration. Hanggang 0 lang. Okay? Hanggang leeg. So, hanggang 0 lang yan. So, hindi natin gagamitin yung 1029. Instead, we will use the other x value, 0.59. Okay? Yun kasi nagme-make sense. Kasi kapag pinag-subtract mo yung 0.75 minus 0.59, positive number yun. So, yun yung gagamitin natin. Okay? So, again, we will always come up with 2x values, no? Kasi quadratic equation 'yan. There are two roots for the for the quadratic equation. 'Di ba sabi sa algebra, kung ano yung highest exponent, ganun karami yung solution. Ganun karami yung value ng x. So in our case, dalawa. So dun sa dalawang 'yon, mamimili ka which of the two will make sense. Kapag magiging negative yung equilibrium concentration mo, that's not it. Also, kapag negative yung value ng x, hindi rin yun. Okay, kunwari, negative something. Hindi rin yun yung gagamitin mo. Okay? So, kailan mo i-reject yung value ng x? If it is negative or it will give a negative a negative concentration. Okay. So, dun tayo sa mga positive concentrations lang. Okay, so I will use x equals 0.59. So, let me plug it here. So, 0.59, 0.75 minus 0.59, and 2x, that will be 2 times 0.59. Okay, so I will get my equilibrium concentrations for each chemical species. For hydrogen gas, that will be 0.75 minus 0.59, okay, 0.16. So the hydrogen gas is 0.16 molar at equilibrium. How about iodine? That will be the same. And then lastly, yung hydroiodic acid natin, HI, 0.59 times 2. That will be 1.18 molar. So that's how we solve for the equilibrium concentrations of our chemical species using the help of ice table. Okay? So I will give you time na lang, maybe after the class na lang. No? You may want to redo our calculations kasi kailangan talaga ulitin nyo yan. No? So you can see kung makukuha nyo tong sagot natin na to. Ito na yung final answer natin. At equilibrium, H2 will be 0.16 molar, I2 will be 0.16 molar as well, and HI will be 1.18 molar. So yun yung ating equilibrium amounts. Okay? Yan. Ayun na yun. Sige, siguro digest nyo na lang muna. No? Okay, moving on. Naka-move on na tayo. Okay, so itong last part, ano na lang to, kwento-kwento na lang. Okay, so kwento-kwento na lang. So let's talk about the factors that may affect the chemical equilibrium. Okay? So itong calculations, paki-recall na lang uli, no? Recall nyo na lang after the class, no? If you have time. Okay, so let's talk about the factors that affect the chemical equilibrium. So as I told you earlier, no, last meeting pa, that chemical equilibrium is a balance, no? Imagine a seesaw na balance yung forces on each end. So ibig sabihin pantay yan. A small change sa either ends, no, sa reactants or sa products, may cause disruption sa balance ng seesaw, no? So yung seesaw mo, pag nilagyan mo ng onting timbang dito, tatabingi na yun agad. Okay? So, ganun din dito sa equilibrium. A slight change in your system can change the equilibrium state. Okay? So, yan, sabi dyan, in most cases, this balance is quite delicate. That means, onting galaw lang sa reaction mo, pwedeng magbago yung system. Okay? Pwedeng mapunta siya sa reactant or mapunta sa product in order to re-establish the equilibrium. And that is what's said by Le Chatelier. No? Iba-iba yung basa lang. Ako, Le Chatelier. Yung iba, Le Chatelaire. Diba? Depende sa accent niya. Pero I will call it Le Chatelier principle. So this concept is briefly described by Le Chatelier, in his Le Chatelier principle. So according there, if an external stress is applied to a system at equilibrium, the system will adjust in such way that the stress is partially offset as the system reaches a new equilibrium position. In Tagalog, Tagalogin natin, sabi diyan, 'di ba may balance tayo? Then a small change will cause disruption sa balance or sa equilibrium. Ang gagawin ng system is that it will re-establish the balance, by adjusting towards the reactant or towards the products, para mag-balance out uli sila. Okay? So, ganun yung mangyayari. Pag hindi na balance yung equilibrium system mo, the reaction may proceed towards reactants or to the products in order para mag-balance uli sila. There are 4 types of changes that can affect the equilibrium na. So, una, change in concentration. The general rule is that increasing the concentration of product shifts the equilibrium to the left. Decreasing the concentration of products shift the equilibrium to the right. Okay? So, ibig sabihin nun, pag dinagdagan mo yung product side, mag-shift yon to the reactant side, because of the reaction quotient. Masyadong maraming products. So, gagawin natin to maintain the balance, you will convert your products into reactants. So, it will shift to the left. Yun yung first sentence. Yung second sentence, sabi doon, kapag binawasan mo yung product side, nagbawas ako ng product side, what will happen to the Q, to the reaction quotient? Liliit yung products. So, that means Q will be lesser than the K. So, the system will shift towards the right, So, some of the reactants will be converted to products in order to balance them out uli, So, yun lang yung general thought, Kapag dinagdagan mo yung products, shift to the left in order to balance out the concentration. If binawasan mo yung products, then mag-shift to the right yan. The same is true for the reactants, Although counterpart lang. Kapag yung reactants mo, dinagdagan mo, it will shift the equilibrium to the right, Dinagdagan mo yung reactant mo sobrang dami na ng reactant. So, Q will be less than K. Mag-shift to the right yung reaction mo. It will produce products. Kapag binawasan mo yung reactants mo, it will shift towards the left naman. Okay? So, in order na maging balance na yung concentrations nila. Okay, so yun lang yung kwento ng changes in concentration. Next one, changes in pressure and volume. Okay, so generally, an increase in pressure favors the reaction that decreases the total moles of gas. So when you increase the pressure, the reaction will proceed towards the side of the reaction which has smaller moles of gases. Okay? Bakit? Kasi if you increase the pressure, your molecules will be clumped together, Magsasama-sama sila. So, in order to maximize their the volume they occupy, gagawin nila, mas pipiliin nila maging lesser moles of gas, para mas maipit sila efficiently. Okay. So again, ang general idea lang for changes in pressure and volume is that if you increase the pressure, it will favor the reaction with the lowest moles of gas. Okay? So tignan mo, sino sa reactant, sino sa product yung lowest moles, dun pupunta yung reaction kapag in-increase mo yung pressure. And a decrease of pressure favors the reaction that increases the moles of gas. Mamaya apply natin itong mga words na to. Ang daming mga words. Changes in temperature. So our reaction could either be exothermic or endothermic. So when you say endothermic, that absorbs energy and absorbs energy or heat. If our reaction is exothermic, it will produce heat. So may criteria tayo to determine whether that's endothermic or exothermic. We use the enthalpy, delta H. So kapag positive yung delta H, that is endothermic. it will absorb energy. If ang delta H ay negative, it will be exothermic, no? So according to this, no, if you increase the temperature, it will favor an endothermic reaction, okay? So, ano meaning nun? Magpo-proceed to the right side yung equation natin. Okay? It will proceed towards the products. Yun yung meaning ng sentence na yan. If a temperature increase, a temperature increase favors an endothermic reaction. That means it will push the reaction towards the right side. And a temperature decrease favors an exothermic reaction. Okay. So yan. To the right side dan kapag endothermic. And then lastly, catalyst. So if we have catalyst, it doesn't have an effect with the equilibrium position. It does not change the equilibrium position. It will only change the rate of reaction, however, at equal changes lang din. Okay, so walang effect yung catalyst pag sa equilibrium. Okay, so again, let's recall, no? Changes in concentration. If you increase the concentration of products, the equilibrium will shift to the left. If you decrease the concentration of your products, the equilibrium will shift towards the right. No? Papunta siya sa product side. Pag pressure and volume naman ang usapan, if you increase the pressure, favored ang side ng equation with the lowest mole of gas. If you decrease the pressure, favored ang side of the reaction that has the highest mole of gas. Pag temperature, kapag in-increase mo yung temperature, okay yon sa endothermic reaction. So that means it will promote the formation of products. Kapag binabaan mo naman yung temperature, that is favorable also with the exothermic reaction to produce the products. And catalyst, walang effect yun sa equilibrium. So let's try some two items here. So we have two items here. Now consider the following equilibrium process and predict the changes in equilibrium. So let us tell whether it is going to the right, to the left. No? When these changes occur to our systems. Number one, reacting mixture is heated at a constant volume. So heated, ibig sabihin increase in temperature. So paano mo malalaman, no? Kung yan ay to the right or to the left, no? To the product side or to the reactant side. Oh, look at your delta H. Okay, so our delta H is positive. That means it is endothermic, no? And ano yung sabi natin kanina? Sabi natin kanina, an increase of temperature will favor endothermic reaction. So that means it will produce products kapag ganun. So ano bang ginawa natin? Tinaas natin yung temperature dito. And since ito ay endo, it will favor the formation of products, no? To the right yung kanyang shift. Tama ba spelling ko ng right? Basta yan. Okay. So the equilibrium will shift towards the right. Towards the right if the temperature will increase for endothermic system. Okay? So endothermic yan. So to the right yung formation niya. Ay yung shift. Okay? Letter B. Some N2F2 gas is removed at constant temperature. Okay. So we have some of your reactants, no, removed from the system. So binawasan mo to. So ano yung shift ng reaction? To the left this time. Bakit to the left? 'Di ba sabi ko nga, in terms of reactants, no, kapag binawasan mo yung reactants mo, the equilibrium will refill yung nabawas, no. Yung magre-refill siya ng nabawas. Okay, so binawasan mo to, gagawin niya yung product, i-convert niya back to kung ano yung nabawas doon. Okay? So ganun. Kunwari nabawasan yan, bibigay to, eto, babalik to papunta doon in order to establish equilibrium. Imagine nyo na lang yung timba, no? Dalawang timba, tas connected sila at the end. Di ba balance yan initially? O pag binawasan mo tong reactants, itong nasa left, binawasan mo yan, what will happen to this? It will push the water to the right side so they will be balanced ulit. No? Yun lang yung nai-imagine ko kapag ganyan eh. Hopefully, makatulong yan. No? Imagine nyo yung timba, they are connected. Pag binawasan mo yung left side, yung water sa right side pupunta sa left in order to make it balance. Okay? So, ganun din. Kapag yung right, binawasan mo yung kanyang dami, yung left bucket, yung water down, pupunta sa right side in order to balance them out. Okay? So, yun. So, that's why if you remove N2F2 gas, the equilibrium will shift to the left now in order to re-establish the equilibrium. Imagine nyo na lang yung timba. No? Pressure is decreased at constant temperature. Dalawa yung cases natin dito. Increase in pressure will favor less mole of gases. Yung side of the reaction kung saan may less mole. Decrease of pressure will favor the side of the reaction with more moles of gases. Okay, so ano nangyari sa atin? Pressure is decreased. So it will favor the side in which dun mas maraming moles of gases. Saan mas maraming mole of gas? Is it the reactant or the product? Obviously, product kasi you have 2 moles of gas in the product side compared to 1 mole of gas in your reactant side. So if you decrease the pressure, the product side will be favored. No? Okay, so to the right yung shift ng ating equilibrium. Last one, catalyst is added. Ang sagot ay no change. Okay, so there will be no changes when a catalyst is added. No? Again, catalyst changes the rate of reaction, pero it doesn't change the equilibrium. Yung rate lang yung binabago niya. Pero yung equilibrium, hindi. Okay? So, no change. Again, so in summary, let's explain again why ganyan yung sagot natin. Mixture is heated at constant volume. So, sabi natin, pag tinaas mo yung temperature mo and you have an endothermic reaction or positive yung delta H mo, it will favor the product side. Okay? So, to the right. Kasi tinaas mo yung temperature in this case. So, to the right yan. Tinaas mo temperature mo, endothermic yan, so it will produce products. To the right yan. What if, sir, binabaan ko tong temperature? It's positive yan. To the left yan, pag ganun. Some N2F2 is removed at constant temperature. So, imagine bucket. So, if you have 2 buckets, reactants product, binawasan mo yung nasa reactant. What will happen? The water on the right side will go to the left side in order to balance them out. So, ganun din dito. So, pag binawasan mo itong N2F2, some of the products will be converted to reactants. So, to the left ang ating shift. Pressure is decreased at constant temperature. So sabi ko, there are 2 outcomes. If you increase the pressure, you will favor the side of the reaction with the lowest mole of gases. If you decrease the pressure, you will favor the side of the reaction with the greater number of moles of gas. So binawasan natin yung pressure. So dun tayo sa side ng reaction na mataas yung moles ng gas. On the left side, we have 1 mole of gas. On the right side, we have 2 moles of gas. So we will choose the right side. No? Kasi binawasan mo yung pressure. So to the right yung shift. And then lastly, pag catalyst dinagdag mo, no change. No? Walang pagbabago. Next item. Okay, so we have this equation here. May typo ako sa delta H. No? Sorry for that. Parehas lang. Let me recheck kung ano yung value ng delta H ko dyan. Saan ko ba nilagay yan? Ito. Wait lang may typo sa delta H. Upload ko na naman ulit ito. Okay, so let me correct that. Hanapin ko lang yung aking material dyan. Positive din pala. 284 kilojoules. Okay, so that would be 284 kilojoules. Yan lang. Okay, so yan. Positive pa rin naman. Let's answer the 4 questions. Kung to the left or to the right yung shift ng equilibrium. Okay? So increasing the pressure of the system. So again, there are 2 outcomes. If you increase the pressure, you will favor the less moles. If you decrease the pressure, you will favor the more moles. More moles talaga. Okay, so dun tayo sa side ng reaction na may more na moles of gas. So anong ginawa sa question? Increase the pressure. So since we increase the pressure, dun tayo sa side na less moles. Sa reactant side, 3. Sa product side, 2. So ano yung mas favorable? So ang mas favorable ay yung product side kasi yun yung may less moles na. So dun tayo sa product side to the right. Okay, bakit sa to the right po? Kasi pag in-increase mo yung pressure, dun tayo sa less moles parate. Okay? Adding oxygen to the system. So dinagdagan mo to. Imagine nyo yung bucket. Dalawang bucket, left, right. Dinagdagan mo ng tubig yung left. What will happen to the water? It will rush towards the product side. No? So when you add reactants, it will proceed papunta sa right. No? Imagine nyo na lang yung bucket na may dalawang bucket na nga eh. So yun, may tubig. Dagdagan mo yung left side. So mapupunta yan sa right. No? So when you add reactants, it will shift towards the products. No? To the right. Okay? So ang helpful ng bucket, na imagine nyo na lang bucket. Decreasing the temperature. Okay? So decreasing the temperature. Lang. So decreasing the temperature, again, dalawang outcomes dyan. Pag endothermic, increase temp, tas endo yan to the right. Okay? Yung shift ng equilibrium. Kapag yan ay exothermic, pag dinecrease mo yung temperature, to the left yung shift natin. I mean to the right pala, sorry. Pares nga pala yung to the right. So in our case, ano tayo? Endothermic pa rin tayo, no? So endothermic yan. Kasi positive yung delta H. Pero ang sabi dito, decrease the temperature. Ang nakalagay dito, if you increase the temperature, to the right yon. What if you decrease the temperature, tas endo yon? E di yung opposite neto. So kung in-opposite mo to, yung opposite mo rin yan. Okay? So if we decrease the temperature, that means you shift the reaction towards the left. No? Okay, so ganun lang. Pag endo, increase temperature to the right, decrease temperature to the left. Pag endothermic, okay? Pag exothermic, decrease in temperature to the right, increase in temperature to the left. Okay? So, ganun lang. So, itong nilagay ko dito, you can reverse the signs, no? Para mas madali, makabisado. Adding a catalyst, no effect. Sana puro ganyan sa quiz, no? No effect. Tapos agad kayo nun. Okay? So, there will be no effect when you add catalyst to your system kasi it doesn't affect the equilibrium. It only changes the rates of reaction. However, the equilibrium will remain as is. No? Okay. So, yan. Ito, madidiscuss to sa laboratory. So, this is the common ion effect. This is an application of Le Chatelier principle. No? This is also commonly used for salts, no? For ionic species, no? Ang kwento dito is that, basahin natin, a salt will be less soluble if one of its constituent ions is already present in the solution. Okay, so suppose we have this equation, no? Anong, ano ba to? KCl. Suppose you have KCl salt, no? So, ano mangyari sa KCl? Magiging potassium yan and then Cl minus. Ang sabi lang dito sa common ion effect, if there are ions existing na common sa iyong salt, no? So, ito yung salt natin. Kunwari, may ions na nag-exist na common sa kanya. For example, I added sodium chloride. So, may additional Cl minus ako doon. So, kapag may common ion tayo, what will happen is that the solubility of the salt will decrease, no? Common ion effect, no? So, actually, ano to, Le Chatelier principle. Okay, so since we have more products, ibig sabihin, most likely to the left yung ating reaction. So it will be less soluble. Okay? So that is true for that is true for precipitates, no. Madidiscuss to sa laboratory with calculations. Although kwentuhan lang natin. Okay, so that is the common ion effect. If you have a salt system and then you add common ions to your solution, it will decrease the solubility uh, of your salt, no, given the Le Chatelier principle effect on concentration. Ang idea doon, dinagdagan mo kasi yung product. So the reaction will shift towards the left. So that means the salt will be less soluble. Okay? So kuha pa tayo isang example, barium sulfate. So itong barium sulfate, it is in equilibrium with barium 2 plus and sulfate ions. What if I added sodium sulfate? Ano yung common ion nila? Yung sulfates, no? Yun yung common ions nila. So since may additional sulfates tayo, then the reaction will shift towards the left, no? So that means baso4, barium sulfate will be less soluble. Okay? So ganun lang. Whenever you have a common ion effect, you have a common ion, pwedeng yung cation, pwede yung anion yung common, it will cause the salt to be less soluble because of Le Chatelier principle. Adding substances to the product side will shift the reaction towards the left. So if you add common ions to your solution, it will shift the reaction towards the left. Or, in other terms, your salt will be less soluble. Okay, so yun lang yung idea ng common ion effect. Calculations for this type of question will be presented in your laboratory class, no? So, i-discuss yun dun for chapter 4. Hopefully, tapos na kayo sa gravimetry, no? Okay? So, that would be all, no? For equilibrium, no? So, in summary, kunin natin lahat ng idea na pinagagawa natin today. So, today, we discovered that we can solve for the equilibrium concentration from initial concentrations. So we started from initial, kinuha natin yung equilibrium. How? We use the ice table or the rise table. No? So paano yung ice table? You create a table, you show the equation, and you track the changes in the concentration of your species, of your substances. So yung I, it will tell you the initial amounts. Andito yun sa problem. Pag wala din sinabi, 0. Yung C, that is the change. We express that in terms of X, no? Kasi we don't know by how much will it change. Okay? So our X could either be positive or negative depending on where the reaction is going. And commonly, the reaction will proceed towards the side na walang product, na walang concentration. For example, ito, 0 yung product. So, the reaction will proceed to the right. Imagine nyo yung dalawang bucket, yung right side walang laman. What will happen to the water? Sa left, it will be pushed towards the right. So, there will be a positive change for the product side, negative change for the reactant side until they establish equilibrium. So itong E, ito yung equilibrium, you just add I and the C. And then what's next? You plug in the equilibrium expressions into equilibrium constant. So you write the equilibrium constant, you plug in this and that here, then you solve for X. Okay, so once you were able to solve for X, you can now solve for the equilibrium concentration. If you have two X's, no, dalawang X na ma-solve mo because of the quadratic equation, you have to choose which of the two X values will make sense. Paano natin ma-determine kung magme-make sense yan? Number one is that if it will give negative concentration, then it is not the correct X value. We have to choose the other one. Yun yung nangyari sa case natin. If I choose 1.029 dito, may negative yung concentrations ko. And that's not good. Ang pipiliin mo ay yung lower X parate. No? Ito pa yung isang reason ba't natin i-cancel out yung X kapag negative yung lumabas. No? Kunwari, negative X to. Hindi mo gagamitin yan. Okay? So, ayaw natin ng negative values na. Always positive lang dapat. So, ganun lang. Still the same process. Nandiyo sa problem yon. Pag wala, edi zero. Okay? Then, you determine where the reaction is going, to the left, to the right, no? And then, you solve for the equilibrium constant. You plug in the E's. You solve for X. Please, ito, favor lang. No? Pakisolve to uli using quadratic equations sa bahay. Nasa bahay naman kayo, no? So, yan. Pakisolve na lang uli yan after the session, no? Check nyo kung ito rin makukuha niya. Okay? So, yan. Then, yan. Once you were able to determine which of the two values of X will be used, you plug it here sa ating equilibrium expression. So, we get the equilibrium concentrations. Okay? So, ganun lang. Itong item na to, di ko to sinagutan. So, I want you to try on this one. So, i-upload ko yung answer dito sa worksheet part 2. Okay. So, calculate the pH and percent ionization of acetic acid. So, acetic acid, kapag may acid kayo, ito, di-discuss to sa lab. If you have an acid, it will dissociate into H plus and it's an ion. Okay? Speaking of, sa lab nga to, naligaw pala tong question na to. Antayin nyo na lang tong question na to sa worksheet ko sa laboratory. No? So, kung iba kasi yung process pala dito. Wala akong binigay na initial concentration, di ba? Okay. So, ibang process to. So, dun ko na lang i-upload sa laboratory. So, wag nyo na lang sagutan to. Kasi iba yung steps dyan. Sa lab pa yung madidiscuss. Okay? Basta for now, ganito na lang muna tayo. Okay? So, ayan. Ito, skip yan ha. Factors affecting equilibrium. Ano lang yan? Le Chatelier principle. A subtle change in the system will cause the equilibrium to shift to the left or to the right in order to offset that change. No? Parang bumalik siya sa equilibrium. So, apat yan. Pag concentrations, isipin nyo yung bucket. Pag yung left, binawasan nyo, the reaction will proceed towards the left. If yung left, dinagdagan nyo, it will proceed towards the right. If yung right, dinagdagan nyo, it will proceed towards the left. At if yung right, binawasan nyo, it will proceed towards the right. So, very helpful dito yung logic natin sa bucket. No? So, imagine nyo, dalawang bucket connected to each other. Pag ito, dinagdagan mo, mapupunta yung tubig sa right side. To the right yung shift. Pag ito, dinagdagan mo ng tubig, mapupunta sa left side yan. Pag ito, binawasan mo, pupunta sa left yan. Pag ito, binawasan mo, papunta sa right yan. Okay? So, that will be the shortcut no, in order to memorize this. Isipin nyo itong dalawang buckets. Changes in pressure. If you increase the pressure, you favor the side with the lesser mole of gas. If you decrease the pressure, you favor the side of the reaction that has the greater moles of gas. Okay, so sa temperature naman, kapag endothermic yan, okay kapag temperature increase na. So increased temperature, endothermic, it will favor the product formation. Pag exothermic yan, decreased temperature, pag exothermic, it will favor the product formation. And vice versa. Yun yung nilagay ko dito sa dulo. Ayan. Okay, so pag binabaan mo yung temperature niyan, tas endo yan, shift to the left. Pag tinasa mo yung temperature niyan, exo yan, shift to the left. Okay? And then also, catalyst, no effect. Okay, so walang effect yan. It only changes the rate of reaction but the equilibrium is unaffected. Okay, so yan. Itong isang item, I want you to answer this na lang. No? So answer this. Use the Le Chatelier principle to predict where the reaction is going. And I want you to solve for the equilibrium concentration. Wala, naggulo na yung spelling ko. So gusto ko, alamin nyo, will the reaction shift towards the left, towards the right? Okay? So sabi dyan, you can compare Q and K to see kung saan siya papunta. And then after nun, determine mo yung new equilibrium concentrations. So I want you to answer this na lang and I will upload the answers by weekends na para may reference kayo. Okay, so that will be all. And before that, yung common ion effect pala, this is similar with our bucket analogy. Sa common ion effect, when we say common ion, it's either one of the two ions produced by your salt. If may common na ion ka dito na nilagay sa solution mo, for example, we have barium sulfate, I added sodium sulfate. So it will shift the reaction towards the left. So the salt will be less soluble. Okay. So pag to the left yan, less soluble na yung salt natin. Kasi babalik yung reaction to the left. Okay. So more of this will be discussed sa laboratory. No? So yun. So again, we're done with the equilibrium concept. We are done with chapter 3. That means by next meeting, we can discuss chapter 4. Okay, so for chapter 3, we will have 2 quizzes for this one. Okay, so 2 quizzes tayo. Hindi pala naka full screen. So we will have 2 quizzes for this one. So ano po yung coverage ng first quiz? Yun yung una kong na-discuss. And then yung second na-discuss ko, yun yung quiz na isa pa. So quiz 3 is the equilibrium concept, how to write K, how to predict where the reaction is going, and ano yung operations involving the equilibrium constant. Yun yung nasa quiz 3. Reduce yung items natin, although 20 points pa rin yan. No? So kapag calculation na sa last part ng Anakem, binabawasan ko na yung questions kasi kawawa naman kayo. No? Hirap-hirap na nga, di ba? 20 items pa yun. No? So ginagawa ko, binabawasan ko yung questions para more time for you to answer the problems. Okay, so ganun. Although times 2 yung points niya, yung iba times 5, no? So ganun. So you really have to be careful sa calculation. That's why I provide worksheets for you to practice with, no? So yan, for quiz 3, itong tatlo yung coverage natin. About the equilibrium concept, how to write equilibrium constant, how to predict where the reaction is going, and how to solve for the basic equilibrium problems. No? Paano isolve yung Kp, paano isolve yung Kc, paano hanapin yung equilibrium concentration nito using Kp, no? So on and so forth. And then, yung quiz 4 nyo, that's about calculation techniques, yung ice table, Le Chatelier principle, and the common ion effect. No? So, yan. So, kailan ko po ito i-open? So, I will open this starting around Friday na lang or kasi Friday na lang. Okay, so for 3 days, this two will be available. No? So quiz 3, quiz 4 will be available starting Friday. Kasi holiday tayo sa Thursday, wala kayong pasok, so you still have time to review during those days. No? So, ayan. Both quizzes will be open on Friday. That will be open until Monday na lang. Okay? So, Friday to Monday yung, yung time frame natin for these two quizzes. And, yan. So, good luck. No? So, hopefully by Thursday, makapag-review kayo. So, yung worksheet upload ko na lang sa Thursday mismo para makapagsagot kayo. Okay? So, yan. So, that will be all for our session today. No? Hopefully, nasundan nyo kahit paano. Okay? Pag hindi, no, ulitin nyo na lang uli yung ating lesson, no? Until masundan. Pero pag hindi pa rin, you can approach me naman anytime, no? So, I know, you may be frustrated at times, no? Kasi parang ang hirap ng anakem, no? Kasi, look, may quadratic equation na tayo. And that's okay. That's normal, no? Uh, Anakem was also my struggle during my undergraduate studies, no? Hirap na hirap din ako sa Anakem dati, no? Pero kinaya ko naman, no? So, hopefully kayo din, no? Yan. So, please check out the worksheets that I will upload na lang for you to practice, no? So, yung Anakem, hindi mo yan talaga masusundan at first glance. You have to review it multiple times, no? Ganun talaga yung Anakem. Ganun siya kahirap mag-get, no? So, ulit-ulitin mo siya until makabisado mo siya. Okay? So, yan. Kasi mahirap naman dito yung calculation, not the chemistry concept. Yung solving, yung mahirap, no? So, yan. So, hopefully, makatulong yung mga worksheets sa review nyo, ha? So, yan. So, worksheet for part 2 will be uploaded on Thursday na lang. Gawin ko na siya bukas para sa Thursday makapag-review na kayo. Okay? So, good luck with your quiz 3 and quiz 4. No? So, I'll see you again next week. No? So, yan. That will be all for our session today. So, ingat po parate. And a copy of the class recording will be uploaded on YouTube. Please tell your classmates na lang. Okay? So, I'll see you again and bye-bye.